Hi everyone, my name is Dibbayandolui. I am a student of College of Engineering and Management, Kolaghat in Electrical Department. Today we will discuss the presentation about Triac, IGBT and GTO. At first, IGBT. The IGBT or insulated gate bipolar transistor is the combination of BJT and MOSFET. Insulated gate refers to the input part of MOSFET having very high input impedance. It is a 4-layer PNPN device having 3 PN junctions. It has 3 terminals: gate, collector and emitter. The terminal's name also implies being taken from both transistors. Gate terminal, as it is the input part, taken from MOSFET, while the collector and emitter, as they are the output, taken from the BJT. The VI characteristics of IGBT. IGBTs have high input impedance, which allows for simple gate drive circuits. They exhibit low conduction losses, making them suitable for energy efficient applications. The switching speed of IGBTs is moderate balancing performance and thermal management. The working principle of IGBT. The two terminals of IGBT collector and emitter are used for the conduction of current, while the gate is used for controlling the IGBT. The second one is the collector emitter is connected to VCC such that the collector is kept at a positive voltage than the emitter. The junction J1 becomes forward biased and J2 becomes reverse biased. The third one, at this point there is no voltage at the gate. Due to reverse J2, the IGBT remains switched off and no current will flow between collector and emitter. Applying a gate voltage VG position, then the emitter negative charges will accumulate right beneath the SiO2 layer due to capacitance. Increasing the VG increases the number of charges which eventually form a layer when the VG exceeds the threshold voltage in the upper P region. This layer from N channel that sorts N drift region and N plus region. The advantages of IGBT: it has higher voltage and current handling capabilities. It has a very high input impedance. It can switch very high currents using very low voltage. It has higher voltage and current handling capabilities. It has a very high input impedance. It can switch very high currents using very low voltage. It has very low on-state resistance. It has a higher power gain than both BJT and MOSFET. It has a higher switching speed than BJT. Disadvantages: it cannot block higher reverse voltage. It is costlier than BJT and MOSFET. It has latching problems due to the PNPN structure resembling thyristor. Triac. A triac is defined as a 3-terminal AC switch that can conduct in both directions. Unlike other silicon control rectifiers, it can conduct whether the applied gate signal is positive or negative, making it ideal for AC systems. This is a 3-terminal, 4-layer bidirectional semiconductor device that controls AC power. The Triac of maximum rating of 16 kW is available in the market. The VI characteristics of Triac. Triacs can handle significant current and voltage, allowing for robust performance. They require a gate signal to turn on but can turn off naturally when the current passes through zero. The ability to control AC power with a single device simplifies circuit design. The operation of Triac: Mode 1, MT1 equal to plus V, gate equal to plus V. Means MT1 equal to positive, gate equal to positive. In this mode, the applied voltage at MT1 is positive with respect to MT2. By applying a positive gate pulse, the Triac will trigger into forward conduction and the current will flow from MT1 to MT2. Mode 2, MT1 equal to positive, gate equal to negative. In this mode, the applied voltage is the same. Mt1 is positive with respect to Mt2, but the gate pulse is negative. Since the gate is connected with the N region of triac, it will trigger it into forward conduction while the current direction will remain the same. Mode 3, Mt1 equal to negative, gate equal to positive. In this mode, the applied voltage polarities are swapped. Mt1 is negative with respect to Mt2, but the gate pulse is positive. The gate pulse will trigger triac into reverse conduction mode, conduction from Mt2 to Mt1. Mode 4, Mt1 equal to negative, gate equal to negative. In this mode, both the applied voltage and the gate voltage are negative. The negative gate pulse triggers the triac into reverse condition. What is the triac advantages? The advantages of triac: once the voltage is decreased to 0, then the triac will be turned off. It can be activated through positive, otherwise negative polarities of gate signals. It can be protected with a single fuse. Disadvantages of triac: as compared to SCR, these are not reliable. As compared to SCR, reliability is low. It will be activated in any direction, so must be cautious while switching on the circuit. The switching delay is high. The rating of DVDT is extremely less than SCR. Triac will have fewer ratings as compared to the silicon controlled rectifiers. It is not applicable in DC applications. The applications of triac: the triacs are used in numerous applications such as light dimmers, speed controls for electric fans and other electric motors, and in the modern computerized control circuits. GTO. The term GTO stands for gate turn-off thyristor. It is a bipolar semiconductor switching device that includes 3 terminals, namely anode, cathode and gate, like a conventional thyristor. It has the capacity of gate turn-off. This device is used to turn on and off the main current supply through a gate drive circuit. This anode sorted structure reduces reverse blocking voltage to around 20 to 30 volt only. GTO VI characteristics: GTOs can handle high voltage and high current, making them suitable for industrial applications. They require a gate signal to turn off, which differentiates them from standard thyristors. GTOs have a relatively slow switching speed compared to IGBTs and MOSFETs. Operation of GTO: forward blocking mode. The GTO is off and it blocks the flow of current in the forward direction from anode to cathode. This mode is similar to a diode in reverse bias. Forward conduction mode: the GTO is on and it conducts current in the forward direction from anode to cathode. This mode is similar to a diode in forward bias. Reverse blocking mode: the GTO is off and it blocks the flow of current in the reverse direction from cathode to anode. This mode is similar to a diode in reverse bias. Reverse conduction mode: the GTO is not designed to operate in this mode as it is not intended to conduct current in the reverse direction. However, some GTOs may have a reverse conduction capability, but it's not a typical operating mode. Gate turn off mode: the GTO can be turned off by applying a negative gate signal, allowing it to switch off quickly. What is the advantages of GTO? The GTO's advantages: the GTO has outstanding switching characteristics. A commutation circuit is not required, hence cost, weight and size can be reduced. The switching speed of GTO is high as compared with SCR. The current surge capacity is similar to an SCR. The blocking voltage capacity of GTO is high. DIDT ratings are more at turn on. Efficiency is high. Disadvantages of GTO: high losses of gate drive circuit. The voltage drop of on state across the gate turn off thyristor is more. The latching and holding currents magnitude is high as compared to SCR. As compared with SCR, the triggering current of GTO is high. What is the application of GTO? Choppers as well as inverters, it is used as the main control device. AC drives, DC circuit breakers, DC choppers, otherwise DC drives, induction heating used in traction applications because of less weight. Low power applications, AC stabilized power. And the reference, Power Electronics book by Dr. P.S. Bhimra and Power Electronics book by Soumitra Kumar Mondol. And at last, thank you. That's it.